How's life in New York?
Life in New York. Life in New York is good. It's getting nicer out, which I love, but it's no Miami. Last time we did this, I was in your neck of the woods, and it's gorgeous. It's gorgeous.
Yeah, it was fun. It was fun having you down here. Going to the Marlins game. Should have went to the Heat game though.
Yeah.
Now they're ahead. Now they're leading 1-0 against the Celtics right now.
Yeah, I just saw the Nuggets went up 2 games against the Lakers, which I was surprised. It's crazy. But yeah, maybe we could do an episode sometime where you come up to New York.
That would be super cool. Yeah, that'd be really cool. But yeah, it's cool. There's just you never get bored down here. There's so many things to do. Like
Right.
Can just go to Miami Beach, pretend to be like a tourist for a weekend. You drive down to the Keys.
Right. Yeah, it was kind of annoying though. The weekend I was there, a lot of the beach was closed for the International Boat Show.
Oh, right.
Which is cool, but there's nothing like Miami Beach.
Well, you weren't in the market for a boat?
Not this time. Maybe next time.
Yeah.
Maybe next time.
Yeah, that's what I forget who told me this. The one thing better than owning a boat is having a good friend who owns a boat.
Yeah. That's a great phrase. I like that one. I like that a lot. Yeah.
Yeah, but no, Miami's great. I mean, New York is super cool too. All you guys from New York came down and flooded the market here and made my rent go up though, so I'm not too.
Yeah, sorry about that. I told them not to do it, but they just didn't listen.
It's okay. It's like they have a mind of their own or something.
I know, it's crazy. But do you have any friends down there that own a boat?
No, not that own a boat. No, not yet.
I was gonna say I'd like to make them my friend too. If you had any of them.
Yeah, maybe I should just start walking around the docks until I make a friend.
Right. That's
who owns a boat.
There you go.
Yeah.
There you go.
I'll just wait for parties going on boats and just tag along. Like, hey guys, I made it.
Or until we could 3D print one ourselves.
Yeah, that's true. Have you seen some of the videos of the giant 3D printers that actually make? Yeah.
Those look mind-blowing. Mind-blowing.
It is. So, it's nuts.
Next SOLIDWORKS live design.
It's just like a robot extruder on wheels. It's like moving around to make the whole thing, right?
Exactly. Yeah, it's honestly kind of the same machine we used to make these action figures, just 20-fold.
20-fold.
Yeah, it's huge.
That's big. That'd be so cool though. Imagine designing your own boat like in X shape and X design, and then just 3D printing it.
Yeah, we should do that. That'd be fun, just in X shape, just to get a nice, what is it called, the hull, nice shape.
Yeah, nice hull. But yeah, what's the biggest thing that you've 3D printed before, Noah?
Biggest thing I've 3D printed. So I made like this deer head sculpture that I did for
that one, actually.
Yeah, it was one of the art fairs here, and it probably was like 7 or 8 big pieces, like full builds, and I glued it together. It's probably it was a couple feet tall. Which is,
you do like the surface finish, and you do anything to it after, like sand it down, or
other than gluing it together? I didn't do any surface finishing. I try not to add more post-processing work if I can, because I like to send the files to other people so they could print it. Right. So if I can avoid them having to post-process, that'd be ideal. But that was probably the biggest part. But you did send me that vase model that I know you did a SOLIDWORKS episode on. Yeah. I would love to print that thing, which is a pretty big model as well.
Yeah, that would be awesome. And maybe we could do an episode just on like printing that in pieces and then putting it together and then actually going through, the surface finish after. Because I would want to finish that and make it nice and
that's a really cool model.
Really awesome. Yeah, that's pretty cool. If you're listening and you want to go see that episode, it's called The Art of Engineering on the SOLIDWORKS YouTube channel. So if you search that, you'll be able to find it. That was a lot of fun and a cool model to work on.
All right. And you did all that in X shape, right?
Yeah.
That's what the episode was covering.
X design. That was actually the first time I did like an arm and like other body parts in X shape. Before that, it was just all right. Well, That'll be a story for another
Right.
time.
Next
Looks like,
episode.
yeah, let's kick it off. Thank you everybody for joining us here for and tuning into the stream for part 2 of a very cool 2-part series on these action figures that Noah and myself created and helped distribute with a bigger team of people behind us at 3D Experience World. My name is Gian Khaleesi. I'm joined by Noah Zeef. The two of us are industry process consultants working for Dassault Systems SolidWorks. And we both have a focus on some of the newer cloud design apps like XDesign and XShape. And like I said, this is part 2. So the first one, I was using Sculptor, 3D Sculptor or XShape to sculpt like the actual form, the geometry of the action figures. But then we had to actually make it work. We had to make it functional and 3D print it. And that's where you come in, right, Noah?
Yeah.
A 3D printing expert.
Yeah, absolutely. Exactly. As you said, this episode is going to be all about how we actually brought that digital model to life. Like you said, part 1 of the series, Gian showed his sculpting skills, and now let's see how we actually manufactured it. So, you ready to jump right in?
Yeah, let's do it.
All right. All right, so here's our lineup of superheroes. Just a bit of background on the project, how this project came to be. This is kind of the human superhero versions of the various X apps that we have available on the 3D Experience platform. And for those that don't know, the X apps are cloud-based applications, so no download required. You could access them through any internet browser. And each one gives the users a different set of capabilities. So I'll just use my laser pointer here to point out an example. We have X Mold on the left, which gives users the ability to create mold cavities and mold cores. On the right, we have X Design, which gives users the ability to design enclosures and assemblies in sheet metal. And the two that we focused on for this project are front and center X Design and X Shape. And these are our 2 core design applications. And for this project, we thought, what if we could turn these 2D superhero drawings into 3D action figures using the very design tools that they offer the customer? So that's exactly what we did. Here are the 3D models made from the 2D drawings. XDesign on the left is an application that offers parametric commands similar to SolidWorks. So extrude, revolve, loft, and many commands like that. Really, XDesign covers most of the design capabilities that traditional CAD designers are familiar with. XShape, however, on the right, offers subdivision modeling or sculpting, which is a 3D design method, but very different from parametric. In XShape, you can treat your models like a digital ball, where you could push and pull geometry in any direction. So we use both of them extensively for this project, which is not only what we recommend doing, but it's actually how they were designed. So you can tackle a complex geometry like this and switch back and forth between the two using XShape to sculpt the muscles, and then XDesign to add parametric details like joints to make the arms and legs move. And if you're interested to see more of that process, we'll drop a link in the chat to part 1 of this XDesign and XShape action figure series, where Gian, as you mentioned, you shared some great sculpting techniques, some tips and tricks. And I would say there are a lot of great information in this video, not just for sculpting an action figure, but really sculpting any type of geometry that would be difficult to create with standard parametric software. So be sure to check out that episode. But today, we're all about manufacturing, how we went from the digital model on the left to the physical product on the right. They look pretty similar, I'd say, almost kind of like twins. So I'm thinking of calling the digital version on the left the virtual twin. What do you think of that name? Totally original. Virtual twin.
Love it. Virtual twin. Digital twin. Yeah.
Yeah. But no, on the right is the final package product. Everything except the cardboard backing and the clear plastic, completely 3D printed. Even some of the packaging itself that held the action figure to the cardboard backing was 3D printed. And we're happy to say these things came out looking like something you'd buy in a store, right?
Yeah, pretty much. It looks good to me. And then once we got to World, What happened with these physical versions? What did we do with them?
Absolutely. So we did only the natural thing to do with something we put months of work into. We gave them away absolutely free at 3D Experience World. But no, this was really a meaningful giveaway because we got to promote an organization that we've been partnering with for years, run by folks that we refer to as actual superheroes. It's called Magic Wheelchair, and they're an awesome nonprofit that builds epic costumes for children in wheelchairs at no cost to families. And with COVID, this was the first time in a few years that we were together in person. So we wanted to do something special, and these limited edition action figures were a fun way to do that. Also, this year at 3D Experience World, we were able to donate $30,000 to their cause. So between creating the action figures, celebrating this organization, it was really a win-win all around. You could check them out at magicwheelchair.org. We'll drop a link in the chat, or you could scan a QR code and help support them in all the great work that they do.
Yeah, it's an incredible foundation, and what those people do, the volunteers in that organization, such caring people, but also so talented. Like, look at the designs that they create in these images here. Like it's really extraordinary.
Definitely, yeah. Every year that Magic Wheelchair product is a highlight for sure.
Yes, always. So we gave these away at World. Did everybody get one, Noah?
We would have loved to give away thousands of these action figures to everyone at 3D Experience World, but unfortunately they were limited edition. So we kind of had a fun competition to give these away. We had a booth where contestants could answer questions based on the action figures design and manufacturing. So day one of the event, the questions were all about their design. How many features do you think they took to produce? How many extrusions and things like that? And then day two was all about their manufacturing. So the questions were like, how many layers do you think they took to print? Or how much material? Or how much time? And I think we're going to drop those questions in the chat as well, right?
Yeah, let's put those questions in the chat. And while you watch here, we'll circle back to those questions, actually. So if you think that you have an answer, as you see pictures of the action figures for how much material in grams you think that it took to build these, how long it took in hours and minutes to actually print them, assuming that each part was printed individually, and then how many total layers of filament, across all components, if everything was printed individually, how many layers do you think that we would have accumulated to get to the final action figure? So those three questions, if you think you have an answer, you want to take a guess, go ahead and throw it in the chat, and we will revisit that towards the end when we actually show you what the real answers were. But that was a lot of fun, it was a cool way of giving away these action figures, and it definitely helped you out if you had a little bit of design knowledge.
Absolutely. And we had some great answers, some really close answers, and some really happy winners as well. Already getting some great answers in the chat as well for those questions. We'll circle back to those at the end. But now for the meat of today's episode, their manufacturing. So I sectioned up the 4 main phases that we went through in the production of these. Going down the list, we started off with design, but this was a bit different than the 3D sculpting design that you had done, Gian. This was more designed for 3D printing or additive manufacturing, otherwise known as design for additive manufacturing. And once we had the product designed with that purpose, we started printing up prototypes. And this was a great example of rapid prototyping because we're able to quickly iterate and pump out a lot of concepts before we created the final model. For this project, we used the most popular form of 3D printing called material extrusion, which you may know as FDM or FFF. Next, it was really important to make these action figures pop with some bright colors because these superheroes had to stand out. There are some limitations when it comes to material extrusion in color, so we'll show you how we got around those challenges. And lastly, the assembly phase. It was unique to this project because we actually designed and 3D printed functional guides and fixtures to help us with that assembly process. So a lot of great stuff we'll cover today. You ready to jump in?
Yeah, let's do it. Let's jump into design.
Yes. So again, a little different than typical CAD. This is design with our additive manufacturing process in mind. And for those that don't know, material extrusion 3D printing is where plastic is fed into a machine. It's melted and extruded through a nozzle, layer on top of layer, like you see here, until a 3D model is built up. And it was important to us that anyone could 3D print one of these action figures if they wanted to, because again, we couldn't give one away to everyone. So we designed them with the most affordable and attainable type of 3D printing in mind. Some of these printers go for just $100 to $200 these days. So really, really accessible.
And that's a great thing to bring up right now too, because we actually just got a question in the chat where somebody was wondering if there's an option to buy one of these action figures. And unfortunately, they're all gone now. There are none left. But we'll get to the end of this episode. You'll have a link to access the file, and you could 3D print it yourself if you have access to a 3D printer. Or like Noah said, they're getting more and more affordable. So
absolutely. Yeah, great point. Definitely a financially viable option to just buy the material yourself and print it up yourself, because the entry to barrier for these machines is so low now. But talking about these machines, there are some things you need to keep in mind when you're printing with them. The first one that I wanted to point out is tolerance. Every manufacturing method has a degree of tolerance, and material extrusion machines tend to have larger tolerances than, say, injection molding machines or resin 3D printers. So we really had to keep that tolerance in mind when creating all the moving parts and joints, because they had really small clearances and tight fits. This also played a role with wall thickness, because some of the features we wanted to include, they could only be so thin before they would just break off, which was obviously not what we wanted with these action figures. Next, we had to consider orientation. Most 3D printing processes are anisotropic, which means that parts aren't equally strong in all directions. So for parts that needed strength, we had to consider what orientation should we print them in to maximize that strength. Also, bed adhesion is a challenge for many desktop extrusion machines. There has to be enough surface contact between the bottom of your part and the bed to make a strong connection so your part doesn't get knocked off mid-build. And this came down to adding flat surfaces strategically for each part that we produced.
Yeah, I remember we had to tinker with those a little bit, because there wasn't quite enough of that flat surface to get it to stick. But I didn't realize that, because Noah, you're the expert with 3D printing. I am a total novice. So this was a big learning experience for me. But that was one of the big things I remember we talked about a lot, is just setting it up to print and making sure that first layer.
Absolutely. And there were a couple tricks that I used along the way, which we'll be sharing later on. So great point to bring that up as well. The last trait about this technology, about these parts that you helped design for, that we printed and we had to keep in mind, was support. Anyone who's 3D printed with material extrusion technology before knows support is a complex issue, because areas that aren't supported enough, they're going to droop down due to gravity, and you're going to get those imperfections. But for areas that you do add support, you're often going to have to break off that support, and that can reveal kind of an ugly bottom surface finish sometimes. So we strived with this project to require as little as support as possible. All the parts were printed and designed with angles in mind that could be self-supporting. So that was some background on the design for this. Done a lot of talking about the action figure. Let's jump onto the platform and actually see this thing. So right now we're in 3D Play, which is a 100% free 3D viewer where you can view any model designed on the 3D Experience platform. And within 3D Play, we have some useful features. One that I want to point out is the exploded view. And we could use this now to see the inner workings of the action figure and how we got each joint to move. So we have our nice exploded view here. We can see all 61 parts that were used to create this this X-Design action figure model. And to make this a fully functioning model, we incorporated 3 different types of joints to get the movement that we wanted. First was the pin joint that we used on the elbow, the knee, and the foot. And this allowed 2 parts to rotate perpendicular around a common axis. The second joint we used was the dog bone connection on the neck, biceps, the boots, and the wrist. And this allowed 2 parts to rotate parallel to a common axis. And finally, for the shoulder and hip connection, we needed more movement, a more complex joint. So we actually incorporated both the pin and the dog bone joint, one on each side. And that way we were able to get both perpendicular and parallel rotation all in one joint.
Yeah, this was a lot of movement going on. So these arms were no challenge to get to, move
Right.
and rotate properly.
Absolutely. A lot of joints concentrated in a really small area. So we had to make every millimeter count.
So I know that we tested out a few different types of joints. We landed here. I really wanted to go with a ball joint at the beginning and just make it like a one size fits all. Just make everything a ball joint, same exact parameters, and then just like cut and paste and everything in every place. But that didn't quite work. Do you remember why, Noah?
Yeah. So I had the same thought at first. Ball joint would allow us to get a lot of motion with these action figures, but unfortunately, we found that joints with the most movement, like a ball joint, the more degrees of freedom, the quicker the material wore down. Because you have to remember, we're using standard PLA plastic for these. It's not exactly the most durable material. So with that ball joint, we found that with all those degrees of freedom, the material wore down so quickly that when we would lift the arm up of the action figure, it would just fall right back down, which is obviously not what we wanted. So we found with these joints, we had a great combination of both friction and wear, where we had enough friction where the limbs would stay in place and the material wouldn't wear down super quickly. So that's why we went with these guys.
Beautiful.
So that's a preview of the model in 3D Play. Now let's take an even deeper dive into this design by opening up the apps that we actually used to create this model. We'll start off with XDesign, which we use to create the test joints to make sure our tolerances and clearances were all tuned in. So this is a test model for our first joint, the pin joint. And pretty straightforward, 2 parts revolving around a pin. In XDesign, we were able to use SmartMates to just drop that pin in place and then kind of visualize the type of movement that we would get. But what was more involved with this joint specifically was getting the clearance right between all of these moving parts. So if we take a look at the clearance that we used here, it actually came all the way down to 0.05 millimeters because we wanted some friction, but the arms and legs had to stay in place after you move them. So this is what we went with, but it's also important to note this was just about at the end of the spectrum in terms of tolerances that our desktop material extrusion 3D printer could handle. A good rule of thumb for assembling these types of joints with this technology is 0.05 to 0.1 clearances will give you room for a reliable tight fit. 0.1 to 0.2 will give you a reliable loose fit where parts will spin around each other, but they won't wiggle too much. And above or below those ranges, you're either going to have too much wiggle or you're going to have difficulty getting those parts to fit at all. So that's how we accomplished the first joint, the pin joint. Now we can open another session of XDesign to see the second joint that we used, the dog bone joint. And just like our pin connection, we can use mates to visualize the type of movement that we would get from this assembly. So in this case, we have 2 parts rotating parallel about a common axis. And if we look into the internals of this joint, we can see where it actually got a bit more complicated. So we could turn on section views to see what's going on inside. And there were 2 reasons that, or 2 important things to note with this specific joint. The first one is notice there's an overlap between the dog bone and the socket. There's no clearance here like there was in the pin joint. And that's because this joint needed a lot more friction to stay in place. So here we actually included a 0.15 millimeter overlap between the 2 parts. Right. And the second reason this joint was a bit more complicated was we had to make sure we could maintain friction after assembly. So we included a relief between the ends of the dog bone, and this allowed the ends to flex inward to fit around the base of the socket in green for assembly, and then flex outward once inside to put pressure on the inside walls of the socket to maintain that tight fit.
Yeah, and that relief probably still could have been a little bit bigger because fitting these pieces together was not easy. I don't
Absolutely.
know.
Which
How are your fingers still feeling, Noah?
I'm still recovering months later.
Still recovering. Yeah,
No, but
Kevin
that's
is.
a great point, which is why we printed those guides and fixtures, which we will include with the files that we share with you.
Yes, the guides and the fixtures definitely worth printing and using.
Definitely. So that was our second joint. And now we can open up the actual action figure in an X shape window to see how this dog bone joint was applied in the arm. So this is our X design model. And just like before, we can turn on section view to see what's going on internally. And this time we're going to focus on the dog bone joint in the arm that's holding together the shoulder and the bicep. So the shoulder in blue and the bicep in green. And the printing characteristic we had to keep in mind here was orientation, because remember, 3D printing is an anisotropic process where parts vary in strength depending on the orientation and the direction that you print them in. So, for example, if someone were playing with this action figure and they wanted to bring the arm outwards in this direction, we would see forces in two primary directions on this joint. One in the same direction as the arm is being pulled on the bottom, and the second in the opposite direction where the shoulder is resisting that movement on top. So these dog bones, these little parts, had to be strong enough to withstand these forces in opposite directions and bring the arm upwards without breaking. And using additive manufacturing's layer by layer process, there was two ways that we could most easily produce this dog bone part. There was option 1 with the layers going parallel to the forces, or option 2 with the layers going perpendicular to the forces. So based off this, seeing how the part would potentially break, let us know in the chat which orientation do you think the layers should be printed on this part to maximize strength.
Yeah, I guess depending on the material, it could go either way, but
Yeah, no, that's a great
pro-
point too. Material would play a role with this. Also,
the processing in general, because I know you said most 3D printing is anisotropic, but
exactly.
are there any that are closer to isotropic?
There are some that get pretty darn close. They do involve some post-processing. Post-processing machines that either add a lot of heat or a different type of, process that could just solidify the part further, so you get better strength and better mechanical properties. But most of the time, when you just take a part out of the printer, it's difficult to get fully isotropic strength.
Right.
But ultimately, I'll pose the question to you, Gian. What orientation do you think we should print this dog bone in to maximize strength so someone doesn't break this arm when they try to play with it?
Well, Brian and Rob and a couple others have actually already answered in the chat saying it's layer orientation number 2. So that is what I'm going to go with. That's it. Locking in. Final answer.
Locking in?
Yep. How do I do?
Drum roll, please. You are correct. 10 points.
Beautiful.
You're exactly right. In this case, we want the layers going perpendicular to that force so we can maximize that strength, and we can have a fun time playing with this action figure. So now that we know how we wanted to print the part, it was also really easy to visualize how we were going to print the part using a handy 3D printing feature that I want to point out. We're going to use on the arm here. So we isolated the arm, and then we can activate Print 3D. And this is a command that's going to allow us to view our parts in a digital print bed to plan out manufacturing without ever leaving our design window. So opening up this command, we have some cool capabilities here. The first one I want to point out is custom build plates. So here I was actually able to input my specific profile of my 3D printer, so I could see the build volume that I was working with, and I could plan out exactly how many parts I could fit. And this was also extremely helpful when we had to plan out the orientation for each part. Because remember, another manufacturing limitation we had to keep in mind with desktop extrusion was that surface contact between the bottom of the part and the build plate. it was really important that every part had to have a flat bottom surface that was large enough to stick well enough to the plate so it wouldn't just pop off mid-build. So
Right.
doing some quick rotations and manipulations here, as well as an auto arrange tool that automatically lines up the bottom faces with the build plate, we could plan out our printing before we actually use any material.
No, what you mentioned before
Mm-hmm.
too, that first layer, don't you use glue as well to try and help seal that first layer?
Yeah, that's a great point. It's not uncommon for material extrusion printers to put down just a glue stick. We're not talking like super glue or
Yeah,
anything crazy like that. Just run over a glue stick over your bed. I've also heard people use hairspray. There's also some products out there that you get creative with. I have great luck with just regular stick glue, so that's what I would recommend. And
yeah,
then some isopropyl alcohol to wash it off after, so you don't get a buildup of glue on the print bed.
right. Yeah, that was a cool tip that I didn't know myself until you showed it to me when we started physically making these things.
Yeah, it was cool. It was a learning process for all
Yeah.
involved. And then let's see here. So this using that principle on finding the best orientation, it worked out for pretty much all of our parts, but it also pointed out some problematic geometry. So if we forget about the arm for a second and look at the head had a lot more uneven geometry. It was definitely going to be a more problematic part, but within Print 3D, we could see exactly how problematic it was going to be by using a support visualization tool. So using this tool, we could turn it on in the dialog box here. We could see exactly how much support we would need by printing this part based on the support threshold that your printer can handle. So right now it's a default value to 45 degrees. So right now we're seeing all the areas highlighted in red that are steeper than 45 degrees and would require support. However, I know with my printer's capabilities and most desktop extrusion machines, they're capable of printing a more dramatic overhang, especially with parts this small. So I increased that angle to 75 degrees, but even with that steep overhang, you can see the support visualization tool is telling me the bottom of the earlobes will still need support. So before we even press print, we know we need to make a design change. And this was the perfect opportunity to jump back in our design software and use that same idea, design for additive manufacturing. So now we know we need to go back to our design and alleviate where we need support. And to do that, we went back into that subdivision environment using X shape, which again turns our model into basically a giant hunk of clay that we could push and pull and sculpt how we want it. And in this subdivision environment, what we want to do here is find the vertice where the ear meets the head and pull it downwards so we could get a nice buildup of material. Just like that. And this is going to make sure the bottom of that ear is not freestanding. And after that quick design change, we can exit the subdivision environment, isolate the head again, and bring it back into Print 3D, where we can, once again do that orientation, plan out its manufacturing, but this time we get to do it with an updated model.
It was pretty amazing that that was the only area that we really needed to change on the head, considering how much other detail was in that and how many other overhangs, like, where the eyebrows come out and the nose. I was very pleasantly surprised at how those turned out.
Absolutely. Yeah. I'm glad we thought of that beforehand, because taking the time to remove that support, it's not only it takes time, but
Oh,
you
it
get
would have
that ugly
ruined the
surface
face.
finish. You're gonna have to sand away those
Yeah, it would
those
have ruined
faces.
it.
Yeah, would have ruined it. Would have been a waste. So we took that into account, and this time when we brought in our updated model and we turned on that support visualization tool and cranked it up to 75, we could see this time we have no red areas under the ear, and they can print freestanding. They're all self-supporting. So that was a bit about how we designed in preparation. for manufacturing. And now it was time for the manufacturing itself. And as we mentioned, we used desktop material extrusion, which allowed for rapid prototyping so we could quickly iterate. And it also allowed us to realize a really helpful approach for this project that I wanted to highlight called agile methodology. So oftentimes the procedure for completing a project is like something on the left called waterfall methodology, where you go step by step once around until you get to a final product. But with rapid prototyping, we could essentially repeat this process quickly through several cycles or sprints. So the final product was really the result of many smaller products. So now let's take a look at what that first sprint, that first cycle of products looked like. We started off printing the test joints on the left that we showed before. And getting these to work properly was a good way to make sure we could get the movement we wanted in the actual action figure without wasting nearly as much material. So we were able to test out the movement of the elbow without necessarily printing the entire arm. Also, in the first design cycle on the right, we had to determine what layer height we were going to use for this entire action figure. And if you've never used extrusion 3D printing before, a difference of just 0.5 millimeter in layer height can have a significant effect on several things about your design, most notably detail and print time. Because the thicker layers you have, you're going to need fewer of them to print your object, so it'll print quicker, but you're also going to lose detail. So we wanted to find a good trade-off between the two. And we chose to run these specific layer height tests on the head because between, as you mentioned before, the nose, the eyes, the eyebrows, even the star on the head, there were so many details on this part that we knew if we could conquer the details on the head, we could conquer the details on the rest of this action figure object.
Right.
So that was how we chose to run those tests on this part. And the results here made the choice pretty clear. We started to see significant drooping under the chin, starting at the 0.15 millimeter layer height and upwards. So seeing that, we would have had to add support under the chin area. And again, that support would have had to been removed. We might not get a great surface finish on the bottom. And our goal here, again, was to have little to no support and little to no post-processing time. So ultimately, we went with the next thinnest layer height that also printed in the quickest time, which was 0.1 millimeters. And we could have gone with the thinner layer height, 0.07, but again, it took longer, and that additional half hour for the head would have translated into a much longer period of time to print when it came to producing 40 or 50 of these action figures.
Right. Yeah, a lot of this was saving time and trying to be as efficient as possible, which is why this first iteration, so cool how we were able to divide and conquer, where I was kind of trying to perfect the head and get that into a good place so we could test the layer height while you were actually building the joints outside of the action figure to see what would work before we actually tried to bring it into the sculpted version.
Absolutely. Yeah. Great divide and conquer project here. And we needed it too, because pretty much all the time you spent designing, I was cranking out prototypes. I was trying to see how can we get all the movement that we want to simulate what, an actual person might move like.
Right.
So that was our first design cycle, printing those test joints and those heads. For the next design cycle, we started incorporating multiple joints. And we saw some early success. The arms moved well, but we quickly noticed some other details that needed fixing. So the collar, for example, the layers were so thin that you could actually see through them. And we had to thicken those up to make sure, it was strong enough not to just kind of be broken off. So a good rule of thumb with this technology, try to keep your printed walls thicker than 2 millimeters to avoid having parts break off as easily. Also, you mentioned this one before, a good bottom surface finish. And the forearm part here was a great example of that because it didn't have a lot of contact with the bed. So when we took the part off the build plate, it didn't have that great finish because I think it kind of wobbled around as it was printing because it was just barely hanging onto that build plate. So what I did in the slicing software was I added a brim. And basically what this did was it increased that bottom surface. So increased the surface area that it had with the build plate, and ultimately made for a much better surface finish in the final product. Let's see here. So there you go. Those are our first 2 design cycles. And that was pretty much our process for this entire action figure, just repeated over and over and over again until we got to the final version. Starting off here on the left with version 4, this is where we started incorporating the pelvis. We also noticed that the joint between the bicep and the shoulder was coming loose. So we increased the overlap of the dog bone joint to make it fit a little bit tighter. For version 5, we introduced the multi-part chest logo, which we'll talk about in the next step for adding color. We also had a thigh in this version that you could rotate, but we decided this made the leg a little bit too flimsy, so we actually took that out in version 6. Also in version 6, you could see we beefed up the ankle a bit because if you look at version 5, a part of the ankle actually broke off. And in version 7, we had all the joints working great, but we wanted a more realistic looking, we wanted more realistic proportions. So in X shape, Gian was able to thicken that torso, move the knee and elbow up a bit, and make the shoulder a little less round. And one version at a time, we were able to get all the parts moving how we wanted until all that was left was add color to really make these things pop.
Yeah, and the whole process of kind of dividing and conquer in the beginning, and then we came together and kind of pumped the brakes on the sculpting and really went in on the mechanism. And then once we knew the mechanism was perfect, like you said, Noah, from version 6 to version 7 was when it was just adding final touches, making it look good, changing the proportions. Like it just looks, if you compare version 6 to version 7 in that picture, you could totally see the difference in the realism on all of those, on all of that, and the proportions really.
Right.
But I have a question for you, Noah. So I know we're showing 7 official versions. How many iterations do you think we actually went through overall, where we would go and make a change, do another print, or just how many of those? How many times do you think that happened?
Yeah, there definitely was a lot of back and forth, a lot of design cycles, and then a lot of smaller design cycles, and then even smaller design cycles. So I would say there were probably 4 to 5 subversions of each arm and leg that I went through until we got something that we were happy with. In total, I would say 20, maybe 30 test prints, test iterations before we got to the final model that we said, okay, everything moves the way we want it now. Let's add some color and let's make it pop. So 20 to 30 iterations, I'd say.
20 to 30. Yeah, that sounds about right. It was a lot of work, but it was worth it.
Yeah. But again, that was the beauty of using 3D printing for this, being able to quickly iterate, rapid prototype. And then, as I mentioned, we could start including color in this action figure. And this was my favorite part personally, because this is where we really start to bring this action figure to life. You know, we got to see what the actual giveaways were going to look like. And we experimented with a couple different ways to add color to these action figures, specifically 4 different ways. We'll go through them now. The first one, the most straightforward, you can see here, multicolor assembly. We did this on most of the action figure, most notably on the chest logo and the thigh, where there were several colors close together. For this, we printed the parts in separate colors, in separate prints, and then just glued them together. So this was really more of a design challenge than anything, because we had to get all those tolerances and clearance to be exactly right to make sure that those parts just kind of fit together like a glove. The next way we were able to add color was on the belt buckle. Now, we could have done multicolor assembly here and glued on the small black X and black circle, but what we were able to do in this case was simply change the material mid-print. So like most desktop extrusion machines, we never had more than one color loaded simultaneously. Instead, in the slicing software, I added a pause at the layer height where the X started printing. And during that time, I just unloaded the white material and loaded in the black material. And that way we were able to get 2 colors fused together on this belt buckle part. And then the third way we incorporated color on this action figure was by far the most complicated, because we had the head with so many colors in such a small localized area with some uneven geometry. And there was no way that we were going to be able to get all those colors on a desktop extrusion machine. So we looked elsewhere, and thankfully we were able to partner with a really cool technology that combined ink printing from regular office paper printers and material extrusion. So each layer that was printed in plastic was then dyed with ink. And that was done in succession until our 3D part was built up. And we did this with a company called Palitra 3D, who helped us out making these heads. They did an absolutely incredible job. So you could check their website out here. We'll also drop a link to them. And we encourage anyone to check them out if they're looking to use full color on a 3D printing project.
Yeah, that one really saved the day for us on this project.
Absolutely. Yeah. Yeah. It would have been really difficult to do it otherwise. But I did experiment with the last way, the most obvious way, which was good old fashioned painting, which is a route that is definitely possible, but it does take longer. It isn't as repeatable, but it is absolutely possible. I did the one here on the right, but probably should have had you do it, Gian, because you're the master painter.
No, it looks good, man. It looks good. He looks a little surprised, I'd say, but other than that, he looks great.
A little surprised, probably because he doesn't have any arms or legs yet.
Yeah, that'd be surprising.
Yeah. So both options very viable for the head part, but in our case, we needed consistency. We're going to crank out 40 to 50 of these action figures, so we needed every head to look the same as the one before it. So full color 3D printing was definitely the answer for this specific project. And then lastly, it was time to bring it all together, to bring it home. And with this assembling all 61 of these parts for this X-Design action figure, it wasn't easy just for one of the action figures, let alone 50. So we printed some jigs and fixtures to make this process a lot easier. You could see one of them here on the left that made it easier to assemble the leg parts. We also included a separate fixture to help assemble the arms. And all of those guides will be included with the 3D XML and STL files that we'll be sharing with you. And Gian, I'm sure you could back me up here. We can't recommend enough to print those guides and fixtures.
Yeah, if you're going to print this, please take our advice and print the guides too.
Save your fingers the hurt.
Yes, your fingers will thank you. We promise.
Yeah. But to take it further, we also printed fixtures that would grab onto the action figure to keep them secure to the packaging. Because remember, we assembled these in our headquarters in Boston, in Massachusetts, and 3D Experience World was in Nashville, Tennessee. So we had to find a way to keep these action figures secure in the packaging with custom mounts. And an easy way to do that was, again, turning to 3D printing. So we 3D printed those. And then once again, we turned to 3D printing to manufacture custom guides. So we knew exactly where to glue on those action figure cardboard packaging guides. So just another use of practical 3D printing to go along with this fun project. And here are pictures of it all coming together, this time including the X-Shape action figure.
I love these pictures, man. It just looks so cool. Well, I definitely really need to know the answers to these questions now. So if you didn't get a chance to answer those questions in the chat just yet, I'll reiterate them one more time, and then Noah, why don't you tell us what the answers are?
Absolutely, yeah.
All right, so the first one was, how long did it take? So how many hours and minutes did it take to print one of these action figures if they were all printed, separately? The second question is, how many layers in total that did it take to make these across each component? And then how much material, so how much what is the mass basically in grams of these action figures? And keep in mind, they're all about 8 inches tall or so, just around that 8-inch mark. But I think we had some answers from earlier where people were saying, I got one for 15 grams for the mass. Let's see the mass one first.
Sure. So for the mass, we did it in grams. And for X design, the X design action figure, it took 91.89 grams to print that model. And just as a frame of reference, typically when you buy a spool of filament, it comes with 500 grams. So it really wasn't that much material when you come to think about it. It was a lot of small parts, but really just small increments of material for each part. So under 100 grams to print these things, which I was surprised about.
Yeah, that is pretty surprising. I would have thought it'd be a little heavier. So a little bit more than 15 than our guest for the mass, but that's all good. All right. So how many layers did that end up accumulating to?
Yeah. So for layers, the X design action figure turned out to be over 8,000 layers. And 8,000. And again, this all ties into those test prints that we ran on the head, experimenting with different layer heights. Because if we had chose a thicker layer height, that number would be a lot less. And conversely, if we chose a thinner layer height, that number could have been over 10,000 layers per action figure.
10,000 layers. Yeah. Wow. Yeah, that's a lot of layers. All right, last question. How long did it take? How long did each one of these X design action figures take from start to finish?
I'll definitely say, I think this number probably surprised me the most. It took longer to print than I would have expected. It took over 20 hours to print all the components just for the X design figure at this specific layer height. Wow. And this is with a machine that prints in, pretty standard print speeds. So it's not like we sped it up or slowed it down or anything like that. It was pretty standard. And yeah, over 20 hours to print that X design action figure.
So for 40 action figures, that's like 800 hours.
Yeah. So we definitely did some batch manufacturing. We tried printing all the torsos at once, all the arms at once, all the heads. So yeah, we tried to consolidate where we could.
Yeah, you had this thing down to a science by the end. It's like an assembly line.
Exactly, like an assembly line in my own little apartment. And we did it.
And your 3 or 4 3D printers all running together.
Exactly, my own little workshop. But we got it done, and now we get to share it with you.
Yeah, so where can they find these models to download?
Absolutely. So first off, if you want the subdivision model, if you want to edit the model that Gian made, maybe you could, give him even more muscles. You could give him some hair. You could remix this model any which way you want. You could go to solidworks.com/action figure model, and that'll give you the 3D XML file. So again, open that up in X shape where you can get that subdivision sculpting environment, and you can have some fun. Then if you want just the printable files, the STLs, you should go to solidworks.com/action figure STL. And again, that includes all the guides and fixtures to help assemble this model. And lastly, if you want to have fun creating something totally new and totally different, be sure to check out the SolidWorks Maker's License, which not only includes X Design and X Shape, which we used to create this action figure model, but it also includes 3D Experience SolidWorks. So that's all for just $10 a month. Really great offer there. And yeah, we'll share a link in the chat so you can learn more about it.
Yeah, that's a great offer. I have it myself, actually. I bought it myself just for my personal projects now. And it's really nice just to have X Design and X Shape right at your fingertips on any device. But yeah, like Noah said, take that 3D XML, so that the model file, you can just drag and drop that onto X Design or X Shape and start messing with it, make it your own. You can make an action figure of yourself.
Yeah.
But for now, absolutely. I think let's close this out. Thank you everybody so much for watching. Thank you so much, Noah, for coming and teaching us all about the 3D printing process for these action figures and the assembly. This has been so cool to watch. I'm loving these pictures, and seeing the whole process is always a lot of fun. But thank you everybody once again. And if you enjoy these live streams, if you enjoy these videos, be sure to like and share them with your friends, and subscribe to the SolidWorks YouTube channel, and be sure to hit that little bell in the top so that you get notified when we have new videos and streams coming out. So thanks. We will see you all next time.
See ya.